All right, so I would encourage you to try number one and two without listening to me do it first, kind of like as a warm up. Um, so do number one and two as a warm up to kind of get your mind working on what we're doing today. So number one talks about Hannah is driving down the highway and she sees the speed limit sign to the right. So the speed limit says 70 and the minimum is 40. So explain what this means. So basically what it means is that your speed has to be between 40 and 70. Right? You can go 40 at the minimum and 70 at the maximum. What are a few speeds that are acceptable to drive? So you could have written anything. I'm going to say like 45, even 41, 68, 53. Okay, any of those, and so on. Okay, so now we want to write an inequality to represent these speeds. So hopefully you were able to say, well, it has to be less than 70, but it needs to be greater than 40. The difference is you can actually write this as a between one. So we talked about this on the first day of 5-1. So you can say x needs to be between 40 and 70. Okay, if you look at this part right here is matching this. And then the first part actually does match this if you flip it around, right? So you're just writing it all together. On number two, it says, how can you use inequalities to describe the set of numbers graphed below? So if we're looking at 2, obviously you have two separate ones here, right? For this one, if we were to graph it, it would be 40 and 70, and you would be going in between them, right? But now it's not necessarily between them. So because it's not between, you can't use the betweenness that we just talked about right here. All right, on this one, we would have to actually set up two different ones. So on the left here, x would be less than -3, right? On the right over here, x is going to be greater than 2. Problem is you can't read both at the same time, so we're going to use the word or, okay? So because you can't do both at the same time, it's that or that, right? Up here, we could have used the word and, right? It's going to be below 70 and above 40 at the same time. So if you haven't guessed it, we're actually going to work with these compound inequalities where there's more than one going on on one graph. Okay, so for number 3a, it says write a compound inequality for the graph, and then we're going to use interval and set notation. Okay, anytime that it is between like this, we are going to try to use the betweenness. So it actually works out really easy because you just put the numbers exactly how it looks. Right? The big thing is you have to remember to put equals to if it is a closed circle. All right. Now you are welcome to put it the other way, but if you do, you have to flip just about everything. Okay, which to me is more work. So I wouldn't go this route, although it is right and I won't mark it wrong. So interval notation, this looks a little different because we aren't going to use negative infinity and positive infinity every single time. We're still thinking the same process. So farthest to the left is -4. So we're going to have a bracket with a -4. And instead of putting infinity, it stops at 1, right? And we're going to have a parenthesis because it is an open circle. For set notation, we'll have our variable such that, and then we'll write the inequality that we wrote above. -4 less than or equal to x less than 1. Feel free to pause the video and try letter B before I start going through it. Letter B is very similar to letter A. So we have 2 and then 6. So because we're shaded between 2 and 6, we know that it's going to be a betweenness one. But don't forget your equal to for 6. Interval notation, we have -2, but it's not included, which is all the way to the left. And then 6, which is included, is our value all the way to the right. Remember set notation, nice and easy. Just rewrite what we wrote above. Similar to number 2 above, letter C, we have 2 separate ones, which means that we can't put it as a betweenness setup because it's not actually talking about being between. So interval, no, well, first off, let's write the inequalities. So this part here is x is less than 3. And on the right, x is greater than or equal to 6. For interval notation, farthest to the left is negative infinity. Then the first spot we stop is right here at 3. So we're going to put parentheses because it's not included. Leave a little space, and then you're going to do a bracket with 6 because that is our next one that is farthest to the left. Or, yeah, to the left. And then all the way to the right is positive infinity. And we'll talk about this in a second, but you should be putting a U between it. And that's just a way of saying or. And we'll talk about it on the next page. So for set notation, same thing. We're going to do x such that x is less than 3. And then put that U again. X is greater than or equal to 6. Letter D, similar to letter C. So go ahead and pause it and try this one on your own first. On the left, we have x is less than 1. And on the right, x is greater than 5. So interval notation, all the way to the left is negative infinity. Our first stop is 1. Then we put a U. Next stop is 5. And then to infinity. So that U kind of takes the place of the middle chunk that it is not including. Set notation, x such that x is less than 1 or x is greater than 5. So let's talk about this whole and or thing. The graph shows the solutions of 2 inequalities. The 2 inequalities form a compound inequality, right? Compound inequality is made up of 2 or more inequalities. So this is where our whole and or problems are, okay? So and is actually the same thing as intersection, okay? And what you're using here, because this is super important, is an upside down U, which I think about because if you put like a line through it, it kind of looks like an A, a capital A, all right? So you could think about it that way. You won't use this very often, but you could if that's your preference. But an and only happens when both are true, okay? And I'll talk about it as overlap, okay? They have to overlap, okay? And you only shade where they do overlap. Sometimes and problems do not have the word and in them, though. For or problems, this is called union, okay? So we have intersection versus union. Now, you don't have to memorize these 2 words, but this is why it's a U for union, okay? Union means either are true, okay? So it's where anything is. Okay, you will always see the word or for or problem. All right, so let's talk about special cases for these. Okay, so just focusing on the graph. All right, x is less than 0, but greater than or equal to negative 2. So if we have 0 and negative 2, okay, I'm going to write it above first. So it would be an open circle at 0, and less than is to the left. Then it would be a closed circle at negative 2, and it's greater than or equal to, so it would be to the right. Because this is an and, we are talking about overlap, and it overlaps from here to here. So we would end up having a closed circle shaded to an open circle. This is a typical one for an and problem, but that's not always the case. So set notation would mean that x is in between negative 2 and 0, exactly like what we saw on the first 2. Our interval notation, just like before, Farthest to the left is -2, farthest to the right is 0. If we take the exact same problem, but make it an OR problem, so it is open and to the left, closed and to the right, just like it was previously. This time, remember with an OR, it's where anything works, right? So that's where anything is covering it. So they have 1 or 2 lines over it, means that you will include it, okay? So you can be less than 0 only, like be over here. You could pick one that's in between it, or you could pick one that's only greater than -2. Okay, either way, all of them would work. So that means your solution ends up being all reals. Okay, so again, you could do x such that x equals all reals. You could just put all reals. I'm fine with that. You could just put it like this if you wanted. Our interval notation, all the way to the left is -infinity, all the way to the right is positive infinity. Doing a similar thing, okay, we have -5 and 7 on these. -5 is a closed circle to the left. 7 is an open circle and to the right. So again, we're talking overlap here, okay? Is there ever a time where both lines are over the line at the same time? That would be a no, right? There's no overlap like there is up here where both of them are over the line at the same time. So because that does not happen at all, that means your answer is no solution. Now this is what you would see as a typical OR problem. Okay, again, this is the same thing. So we would have the same exact graph. This is what you would typically see, but not always, for an OR. So again, our solution would be -infinity to our first number, which is -5, with a bracket because it is included. Then we have U for union or 7 to infinity. Oh, these should be flipped. That would be interval notation. And then for set notation, we would have x such that, and then we write our two inequalities. X is less than -5, union, x is greater than 7. There is one more type of special case. So we have -2 and 4. -2 would be open to the right, and 4 would be open and to the right, okay? Again, with an and problem, you're talking about overlap. So the only overlap you have is from here on, right? That's where both lines are. So we would have an open circle shaded to the right. Okay, so this doesn't even look like a compound inequality because the -2 really doesn't matter. So if we have set notation, x would just be greater than 4. Interval notation, we would go from 4 to infinity. So with the same problem, if it is an OR problem, ORs are where one, both, or the other are included. So for ORs, you would go from the -2 over because there's one from here to here, but then there's both here on, right? So you need to include both of them when it's an OR. So set notation, x such that x is greater than -2, and you would go from -2 to infinity.